In my last video, I explained Newton's first law. Every body continues to be in a state of rest or of uniform motion unless compelled by an external force. That means if you want to change the velocity of a body, force is to be applied. Then when velocity is changing, momentum will change. Momentum is the product of mass and velocity. That means without force, momentum cannot be changed. So Newton's second law relates the force with the momentum. Force is equal to the rate of change of momentum. In the notation of calculus, we can write a dp by dt. That is the rate of change of momentum. Then for momentum, we can substitute mv, mass into velocity. Then in classical mechanics, mass is a constant. But as per Einstein, mass is not a constant. When particles are going with a very high speed, mass will change. But in classical mechanics, mass is a constant. So you can take mass m outside, then dv by dt. dv by dt is the rate of change of velocity. Rate of change of velocity is acceleration. So we can write F is equal to ma. Force is equal to mass into acceleration. That means to produce acceleration, force is needed. From this relation, we can define Newton. Newton is the unit for force. 1 Newton is the force acting on a body of 1 kilogram and produces an acceleration of 1 meter per second square. You take a 100 gram object on your hand, then you have to apply a force to keep it. Then the force needed, that we can calculate from this relation, F is equal to ma. Acceleration due to gravity, that is F is equal to mg. Instead of a, we can write mg. Then 100 gram. So when you express in kilogram, 0.1 kilogram. So for this m, you can write 0.1. Then acceleration due to gravity, 9.8 meter per second square. But approximately we can take it as 10. 0.1 into 10, that is 1. So 1 Newton. If you keep a 100 gram object on your hand, you have to apply a force of 1 Newton. That's the meaning of the Newton. The unit force is measured in the unit Newton. Now let us make a comparison between Aristotle's idea and Galileo and Newton's idea. Newton's law could explain the motion of object on an inclined plane. Here there is an object on an inclined plane. When it is coming down, after reaching the ground, as per Aristotle's idea, it should not move because there is no force in the horizontal direction. But you know it will move. After moving, it will stop after some time because a frictional force. Suppose a frictional force is not there, it will continue its motion. Then this is Aristotle's idea. If a body is to move with the constant velocity, external force is needed. So here net force is equal to external force. Here body is moving with the constant velocity. Then here also body is moving with the constant velocity, but frictional force is acting this side. Then external force is acting that side. So it is equal. If it is moving with a constant velocity, net force will be 0. External force that side, frictional force this side. So net force is 0. So if a body is to move with the constant velocity, force is not needed. Net force is 0. So, but as per Aristotle's idea, if a body is to move with the constant velocity, external force is needed. If a body is to be maintained in motion, external force is needed. But here, as per Galileo's and Newton's idea, external force is not needed if a body is to move with constant velocity.